Super. Okay, let's go ahead and get started. So it's a pleasure. Welcome, everybody. It's a pleasure to have our first Science Museum lecture of the spring semester starting off tonight with a neat local topic, looking at some of our regional fisheries resources and some local examples as well. My name is Scott Newbold. I'm a member of the biology faculty here at Sheridan College. I help coordinate the Science Museum lecture series, and the lecture series is brought to us by the Sheridan College Museum of Discovery with support from the Sheridan College Foundation and from the Life Science Department. We've had speakers coming for over 2 decades, and it's a neat way to share some of the science expertise and some of the studies and the projects that are happening both locally and statewide. It's my pleasure tonight to introduce our speaker. Gordon Edwards is a fisheries biologist with the Wyoming Game and Fish Department, focused on generating data-supported management recommendations within the Sheridan Fisheries Management region. Gordon's education and training include an associate's in biology from Sheridan College, a bachelor's in wildlife and fisheries biology and management from UW, and a master's in natural resources with an emphasis in fisheries management from University of Connecticut Storrs. Prior to arriving in Sheridan in 2018, or more accurately, returning for this Sheridan native, Gordon served as a fisheries biologist in Utah and most recently in Casper. When I asked him how he got started in the fisheries world, he told me his first fisheries career experience was a summer practicum with the fish crew here in Sheridan, set up by Marion Klaus, who was a professor in the biology department at Sheridan College at the time. After that summer experience, and I quote here, Edwards said, "Dare I say, I was hooked." Tonight, he's going to share with us a story about radiotelemetry of migratory fishes in Clear Creek and Powder River in Wyoming. Thanks, Gordon, for joining us tonight.
Yeah,
last moment. Sorry, Gordon. Last thing, audience, there is a way to submit questions. I think we've discussed that maybe it's easiest if you just submit those anytime during the lecture, and then Gordon can tackle those questions at the end. He'd be happy to. There is a place at the bottom of your screen, a Q&A box where you can click and then submit those questions. And we encourage you to submit them anytime you think of them. All right. Thanks. Thanks again, Gordon.
Yeah, thank you, Scott. That's really nice. And I'm also known for bad jokes too. So that was good to get that in there. But yeah, I'm really pleased to be back here and happy to be here tonight to talk to you folks about a new exciting project where we started last year and hope to learn a lot more this year and maybe into the future beyond that. I'll go ahead and share my screen and then we can get into the presentation. So hopefully this works okay. Does everybody see that now, I hope? And okay. Should see my first slide there. So yeah, we're talking tonight about a new project to study large-bodied fish migrations and movement patterns using radiotelemetry in Clear Creek, the lower portion of Clear Creek in the Powder River in Wyoming. It's a project focused on 3 species in particular, but we're going to learn a lot about a lot of other species of fish too. The primary funding for the project comes from state wildlife grants, which is federal money that helps the states manage native and non-game species. And we also got some funding from the governor's ESA account for some of the equipment. I'd like to just take a moment right up front and acknowledge a lot of the help that I have with this project from other personnel here in the Sheridan region, Paul Mavrakis, Andrew Nykirk, Travis Cundy, of course, Reed Moore. And then also, we couldn't do it without our partner, which is Stephen Siddons with the Aquatic Assessment Crew. That's our statewide research crew out of the Casper and Laramie regions. Also, I really want to thank Montana Fish, Wildlife, and Parks. They're a huge help with everything we're doing. This is all new to me, especially, so I'm learning a lot. And of course, to all of our really awesome landowners that are helping us out, including the Ford Ranch Trust, and Kathleen Holcroft, and many others along the Powder River, the PG Ranch, Bob and Carol LaResh, and Mike Mitzel on Clear Creek and his family too. So what I'm going to do today is just really give you a lot of project background. I'm going to talk a bit about the study area, our objectives, some methods that we're using, and then kind of get into some of our kind of early methods. But so far it's been pretty neat. So it's mostly an informational talk. I'm going to, again, talk a lot about the fish community that's there to give you some idea of what the Powder River and Lower Clear Creek are like as a place to live as a fish. And then I'll get into some history of the surveys and give you some project background. And then we'll get into the telemetry project design, the progress that we've made, some of our early results, and maybe where it'll head into the future. So the area that we're talking about tonight is the Powder River Basin in Wyoming, which includes a couple major tributaries. In this case, primarily Clear Creek and also Lower Crazy Woman Creek. And I don't know if you can see my mouse moving there, I hope so, but that red outlined area is the Powder River Basin, which extends north from pretty close to Casper. But the forks come together near KC and flow for over 200 miles into Montana. And then the major tributaries include Crazy Woman Creek and then Clear Creek, which we're really just talking about the lower portion of it. There are no major impoundments on the Powder River, very limited irrigation withdrawals from the Powder River itself, and very little civil development. It's still a pretty relatively wild place. It's a really large watershed with many lowland and ephemeral drainages. And the headwaters do provide some snowpack contributions through the perennial tributaries, such as Clear Creek and Crazy Woman Creek. And you may have heard of the Middle Fork of the Powder River, which is a really well-known trout fishery, but that's really where the association with trout ends. So if we zoom in and look at two different maps here, if you look at the left one, we're just focused in on the Powder River drainage from its headwaters near KC to where it dumps into the Yellowstone River in Montana. It's about 450 miles long. Its headwaters, of course, start in the southern Bighorn Mountains, and it fluctuates a lot in Wyoming. It gets that spring melt runoff pulse of water, but also it's really influenced by a lot of spring rainstorms and things like that can rapidly change the water flow. And it can also in late summer literally almost go dry. There are portions of it that go intermittent, which is fairly normal, although rare. And then Clear Creek, if we look at that tributary, that's one of its major tributaries or contributors in Wyoming that flows into the Powder River just before it hits the border. It's much different. The habitat is very different than the Powder River. There is a lot of irrigation withdrawal that occurs on it throughout its length. And if we skip, sorry about that, we skip over to the right side, we're zooming in a little bit more, and that red squiggly line, that's a section of Clear Creek that is a major focus of our study. That red portion represents the reach of Clear Creek that is now accessible to fish moving upstream since a passage project was completed on a major dam, the Kendrick Diversion Dam, in 2010. And so a lot of our project is focused on that 36 miles of Clear Creek there that was inaccessible to fish for over 100 years, and now has been recolonized in large part by a lot of the native fish and other fish that were able to move upstream after that project. And the Clear Creek and Powder River do both share a lot of the same species, but they are very different habitats. So fish use both of those in different ways during different parts of their life histories. The Powder River itself is considered an exemplary Great Plains river. It has these wide-ranging stream flows that often, in the summertime can be between 200 to 1,000 cubic feet per second. But late in the summer, after things dry out, like I said, there can be some pretty frequent intermittent periods. The water temperature can exceed, nearly 100 degrees. It's either going to be really muddy and turbid early in the year, or literally just crystal clear when the runoff stops later in the summer. It's very sandy, shifting bottom habitat, very little overhead cover or aquatic vegetation. So really not a whole lot of physical cover for fish. But although it seems like a really harsh place for fish to survive, the native fish that live there evolved to just thrive in that habitat. And many of them also use the tributaries. So if we look at Clear Creek, in contrast, it's quite different. It does have wide-ranging stream flows that are mostly centered around that runoff period when flows come up and then drop back down after the snow melts. And the major difference in its substrate is that it has a lot more coarse gravel on the bottom, a lot more stable banks, a lot more woody debris and things of that nature that create more physical habitat for fish. So it's a very different habitat, but even so, it does share a lot of the same species. So if we look at what fish you'll find in the Powder River and Clear Creek, it is the highest fish diversity in the state. We have 9 different species of native minnows there. There are 5 species of suckers. You have 3 different species of catfish, and these 3 highly migratory species, the Shovelnose Sturgeon, the Sauger, which is basically a native cousin to the walleye. It's in the same genus as a walleye. It looks a lot like a walleye, but it's actually native to Wyoming where the walleye is not. And the Goldeye, which is kind of a herring-looking fish that you'll find in large numbers in places like the Yellowstone River. It's a big river, big turbid river fish. And then there are 6 exotic or non-native species found in the Powder River, but they're fairly rare in comparison to all the native fish, because in reality, the Powder River itself is a fairly harsh place for these fish. It's one of the few places that you'll find carp just kind of merely scrape by. And the tributaries often do have habitat that's more suited to these fish than the Powder itself. So those like Clear Creek and Crazy Woman Creek kind of serve as the source populations for where those non-natives kind of hang on. To give you an idea of just a handful of some of these fish, smaller bodied fishes anyway, the sturgeon chub in the upper left there is a fish that the Powder River is one of 2 places that it's still found in Wyoming. It likes to live in swift main channel habitat with kind of coarse sand and gravel bottom. The stonecat in the bottom left, that's a species of catfish that's generally pretty small. It likes to live in rocky cobbly habitat where it can hide and really hunt invertebrates, insects and things like that in amongst the rocks. And then the 2 species on the right are species of minnows, the Western Silvery minnow and the flathead chub. They might look really similar, but they're very different fish, where the Western Silvery minnow is one that's well known to travel great distances in order to complete its life cycle. This one is literally ready to pop with eggs. That was sampled in the Powder River near Interstate 90 a couple of years ago. And it's actually declining throughout its range for various reasons, where the flathead chub, which is kind of also, these are both habitat generalists. They kind of just use a lot of different habitats in a prairie stream. The flathead chub's doing very well in a lot of streams in eastern Wyoming. So that's just a handful of all those fish that you'll find out there that are smaller. The larger fish that are present in pretty big numbers in the Powder River include the shorthead red horse. That's a species of sucker. And the top left there, the river carp sucker. These are both kind of main channel, big water fish. They like swift runs and pools. And then channel catfish, which are native to the Powder and Clear Creek. And you might not think of channel catfish as really a migratory species, and they often do kind of stay in a single pool for a lot of their life. but they do make large movements. There was a fish that we tagged in 2008 in Clear Creek when I was on the statewide research crew helping out with the project up here, that later turned up in the Yellowstone River 5 years later. It was a lot larger. An angler caught it near Pompey's Pillar, which put it, nearly 450 miles away. So even fish like the channel catfish sometimes find good reason to move a long ways to complete their life history. So the focus of our project for telemetry, radio telemetry, are these three species: the Shovelnose Sturgeon, the Goldeye. So this is the herring-like fish that I was talking about, and Sauger, which you can see here does look somewhat like a walleye. And our goal was to radio tag Sauger, Goldeye, and Shovelnose Sturgeon, and just observe their movements intensely for a couple years. And we wanted to coordinate this with Montana Fish, Wildlife, and Parks because they do some serious telemetry work up in their country in the lower Powder River, the Yellowstone, and the Missouri. And we just wanted to see, how these fish really moved regardless of what the stream flows were, and try to learn about what their patterns of behavior were. And so we've done this different ways in the past, but found a lot of difficulty. Stream flows get really high and we have a hard time capturing fish. And so we just get these little snapshots, and being able to use radio telemetry allows us to basically find these fish almost at any time and see where they're at. And so we can look at it in a new way. So I'll give you some background on fish survey work in the Missouri River Basin in Wyoming, particularly the Powder River and Clear Creek. Early game and fish surveys really focused on finding places to establish fisheries for the public's enjoyment. And more or less that meant looking at streams and deciding if it was worthwhile to try to stock trout there or not. But that generally, kind of evolved as, time and resources were more available to just learn about what was there still, or what had been there before maybe the habitats had changed. So, there was a shift in management interests and kind of an acknowledgement of the game and fish's responsibility to manage non-game species. And so, leading into the 80s and 90s, this had started, but in the 80s and 90s, there was some graduate research of these native fish populations that started to occur. And we really got our first solid baseline information in the Missouri River Basin through some graduate research that was done at the University of Wyoming. And then in the early 2000s, the shift became, at least in the Powder River, to look at potential effects of industry development that was happening there, the coal bed methane boom. Like, what effects might that have on the fish population and the aquatic environment in general? So, that was kind of the next big phase of projects that occurred, both by Game and Fish and other partners, and also some graduate research. And then interest really grew in pursuing fish passage projects. In other words, trying to create ways that fish could move around barriers so that their populations could grow, or they could reestablish in places that they'd been before. And that included a project to create fish passage around the Kendrick Diversion Dam on Clear Creek in 2010. So this is what that dam looks like on Lower Clear Creek, about 7 miles, I believe, upstream of its confluence with the Powder River. It's a very sturdy dam. It was once owned by our first territorial governor, John B. Kendrick. Built in 1901, it's about an 8-foot high drop that, after it was built, was a complete barrier to upstream fish movement. So obviously, some fish that don't move a lot stayed up there and retained populations, things like northern red horse and other fish as well. But many of them that needed to move a long distance to complete their life cycle, or if changes to the creek upstream affected those populations, they disappeared from upstream. and weren't able to recolonize it. So that was something that we worked on. Our aquatic habitat biologist, Travis Cundy, worked very hard with the landowner there to figure out some kinds of solutions. And eventually, after several years of negotiations and working really hard to figure out ways to, not affect their ability to get water from Clear Creek that they needed, they built this bypass channel. And what you're looking at in the big picture here is the creek flowing from left to right. So it's flowing downstream from the left side of your screen to the right side. And that channel across the bend of the creek is the fish passage structure. If you look at the bottom picture, you're sort of rotated to that upstream end of it flowing downstream to the upwards portion of the picture. And you can just see how there's like a control gate and then a rock line channel with some little velocity breaks in it that basically empties out right below the dam. And I have some more pictures that I'll show you here. It's really part of Travis's legacy. It was a major accomplishment. This is what it looks like when you're down on the channel or near the channel. Looking downstream, you can see these large rocks that were engineered to allow most fish that were present there, as far as the engineers could tell, enough of a break in velocity that they could move around and make their way upstream. And with water in it, this bottom left-hand picture kind of shows you what it looks like staring right straight up at that control gate. So Clear Creek's right on the other side of that. And the bottom right picture, you can see this is where the bypass channel enters into Clear Creek right below the diversion dam. And that turbulence right below the dam was important because it was felt like, fish are basically going to bump their head up against the dam, but also they're attracted to that sound of that turbulent water, and hopefully they make a turn and go upstream. So when it's operational, and it was opened on April 14th of 2010 for the very first time, it works very well during most peak flows, although when Clear Creek exceeds about 2,400 CFS, which the average peak flow in a 10-year period is somewhere around 1,700, the gates in that structure that let the water flow down the channel are submerged, and it creates a velocity barrier. But for most of the year and most years, it works pretty darn well. And here's some more pictures of that control structure at the top. So this is looking at the structure where we have some a trash rack basically to collect debris, which keeps fairly clean, but we do have to occasionally go out there and clean it off when flows are really high and there's a lot of debris in the stream. And I think the top right shows Travis turning it on for the very first time. It's a very proud moment for him to do that. And of course, right after it started functioning, everybody was really excited to see how it worked. And so this is my predecessor, Bill Bradshaw, right here. I think that's Bill anyway. He really spearheaded an effort to initially try to figure out, how well this worked and for what species it worked. And we tried a few different things to figure that out. Bill tried what you're seeing here, looking straight down on this, what's basically a modified fyke net or a trap net that funnels fish upwards. The stream's moving out of the gates from the bottom of your screen to the top of the screen. So that's downstream. And so fish swim in there and get funneled into a bag basically, which worked fairly well, but only up to about 1,000 cubic feet per second of water in Clear Creek. So when flows were too high, it just basically blew it out. So it wasn't completely effective, but we did learn and find some species of fish were using it. Bill's better mousetrap, as he called it, was this picket weir, which is more or less a series of aluminum rods in a channel that work better into higher flows. But it seemed that some fish still avoided that trap. So fish would come along and hit basically the fence, and then they'd encounter the trap and swim inside and kind of get confused because of the wings. But some fish really just didn't like it, didn't go into it. So it helped, did a little bit better, learned a little more, but still didn't work completely. So, we also tried another technique using what's called passive integrated transponders. They're basically pit tags, or the type of tag that pet owners end up with in the neck of their dog or their cat, that you can scan a device over it and it'll identify a number that's associated with your pet. Basically, we can inject those into fish, and with an antenna in the stream and above the stream, you can often detect fish that pass by, but it's not foolproof, and there were some problems with that as well. So we thought that when we had the opportunity, we'd try something new. So this current project is kind of trying to bridge that gap and look at the stream in a new way, more or less. So that's where this new project comes in. And its goals are really to compare the fish populations before and after the fish passage project was completed on Clear Creek itself a decade later. And really, try to see if we had an opportunity to move further upstream, which we don't right now, but maybe in the future we might have that opportunity. Would it be worthwhile to try to pursue further fish passage and see if it would help to move the fish further upstream? We wanted to also just describe seasonal fish migrations better using radio telemetry. So we can detect fish movements and locations in any flow without capturing them. And also, kind of the most exciting part about it that I'll talk about at the end is we might detect some new species that might return to Clear Creek after a major fish passage project is completed here in the very near future, basically in a couple months. So I'll go into that here in a little bit. So how we were tackling this telemetry project, the nuts and bolts of it, the core data that we're collecting, is using what are essentially stationary telemetry receivers. So these are fish tracking stations that are located where you see these stars. They're strategically located, two of them on the Powder River, one near the border with Montana, one upstream of Arvada, just downstream of the Crazy Woman Creek confluence. And then we have two on Clear Creek, one right below the dam, and then one is about as far upstream as we can get it. It's just below where that next barrier to upstream fish migration is at. And these, when they're running, are basically listening for fish with radio tags in them 24 hours a day, 7 days a week. And we also collect data from those that is directional. So we can detect a fish that moves from upstream to downstream and vice versa, looking at the data a certain way. So it's a new way of doing things here, and it's unique. This is what one of those stations looks like. It's pretty a standard setup that we copied from stations and that they're used in Montana. And it is what you think. It's basically a radio listening for signals. And so we have these two antenna, one pointed upstream in this case, and then downstream. This is the station at the Montana border on the Powder River that runs the signal into the electronics through a coaxial cable, and then a solar panel to keep a couple batteries charged, and a fence to essentially keep the cows, hopefully, from destroying it. And that's worked so far, so good. And if you look inside that box, this is what you'll see. Basically, it's powered by two standard 12-volt deep cycle batteries that we bought at Napa. And you'll see the power cables coming in and going to a charge controller to maintain those batteries so they don't get overcharged, and to reduce the voltage from the solar panels. And then the coaxial cable from the antenna enter this box, expensive black box essentially on the side, which is the radio receiver that is able to continuously log data from scanning certain frequencies. And each of these radio tags that I'll show you here in a moment also records an individual identification number for a fish. So we know what fish it is, which means we know what size it was when we tagged it and what species it was and where it came from, if it's our fish or if it's Montana's fish. So at any rate, that's what the electronics look like inside. And so once this is set up and tuned and it's running, basically all we have to do is come back and check on it, make sure it's still physically there and not destroyed by lightning or bullets or something of that nature. But we can download the data onto a laptop and kind of give a look through it to make sure that it's making sense, and also look for fish identifications or detections. And any of the detected fish that we might see at one of these stations tells us, well, that fish is now upstream or downstream. And if it's in a place that we can go look for it, we could go do that. Of course, to do that, you need fish that are tagged in the stream. So one of our major goals this last year was to get as many fish tagged with radio tags as possible. And you can see the tags in this little inset picture. This is a quarter for reference. The tag on the left is a pretty large tag. It's like the size of a 38 caliber bullet or something like that. Well, no, it's bigger than that. I guess the tag on the right is more about the size of a 38 caliber bullet. And the reason the tags are different sizes is that there are limits to what you can put in a fish and minimize the effect it has on its behavior. So obviously, you could put a bigger tag in something like a shovelnose sturgeon. So that larger tag, that's what that is a tag for a shovelnose sturgeon. And the smaller tag on the right is a tag that we put into a sauger, which is very similar to what we put in the Goldeye, but they're even smaller. So it actually has a little bit smaller size because it has the smaller battery. So in effect, the smaller the fish, the smaller the tag, and therefore the smaller the battery, which means you have a shorter battery life, unfortunately. But that's just how it works. We aim to put a tag in a fish that doesn't exceed about 2% of its body weight. And then also the tag settings, like how frequently it broadcasts its signal, and other features you can add can affect its battery life as well. So the battery life for our shovelnose sturgeon is advertised at about 882 days, where Sauger, it's about 565 days and only about 300 days for the Goldeye. So that's how those work. And they're pretty expensive tags. And so with the budget that we were given, we just tried to strategize, what we could realistically catch. And, we didn't want to put too much money in the most expensive tags and not be able to put them out when we'd be better off having more of our smaller fish out there. So that's what we tried to do. And to catch those fish, in order to implant radio tags into them, we used whatever methods were most appropriate for the conditions we were given. And flows made that pretty difficult, but we did do pretty well. It's always very challenging. The primary method that we used were trammel nets that we drifted in the streams. So you can see in the bottom right, this is a net that looks a lot like a gill net, only it's made of a multi-filament material, and it's essentially a sandwich of several net meshes. So a fish that encounters it gets pocketed and it doesn't get gilled and injured as badly as it would in a gill net. And we used electrofishing in Clear Creek itself, either in a raft that we rode in or in a smaller raft that we would wait alongside. And that's in effect using electricity just enough in certain ways to stun a fish, net it, and then capture it so that you can put a tag into it. So we did also attempt some trot lining for sturgeon, which is like putting a set line out there that's baited. We didn't have much luck with that. So it was primarily drifting trammel nets in the Powder River and electrofishing in Clear Creek. That's how we captured the fish. And then it was time to surgically implant the radio tags, which the techniques for surgically implanting those tags in shovelnose sturgeon and sauger are very well established. but we didn't find any studies that had been done with telemetry on Goldeye. So that was something we had to experiment with, because they have kind of an odd flattened compressed body shape, but we figured out a technique that seemed to work, and our fish did survive very well. So the basic procedure for all the surgeries involved, capturing the fish and then putting them in a cage in the creek. And then while we're preparing the gear, we'd anesthetize the fish in, say, a tub or a bucket, sterilize the equipment. And then when we're ready, we place the fish in a surgery cradle and make a small incision near its pelvic fins. We use a needle to thread the antenna behind the incision and then pull the tag into the body cavity. And then just use some simple sutures to close that up. We place the fish back into a cage in the creek for observation until it recovered. And then once it was deemed to be doing really well, we just release it. And of course, we would test the tag before we release the fish to make sure it was still working. So it was pretty simple. It's kind of nerve-wracking the first few times you do it, but eventually it becomes pretty routine, and you get better at it. And then it's just a matter of looking for them. So we did that several different ways. Of course, we had these receiver stations. This is the one on Clear Creek right below Kendrick Dam. They were listening 24/7 for tagged fish and logging the data. Opportunistically, we look for fish on foot using a mobile antenna and the same receiver in a bag. It was battery powered, smaller batteries, and also by aircraft. And we didn't get as much of the flight tracking done last year as we wanted to, mostly because we were really focusing on getting tags out as much as possible. But that's really something crucial. We're going to try to do more of this next year. But after you've collected this data and you have locations of fish at a certain time in a certain place, it seems like it sounds pretty clear cut, but it takes a lot of time to sort through that. And what you end up with essentially is detection histories, or each individual fish has a history of where you located it. And then you can look at patterns in where that fish was located and where it ultimately ended up. So that's kind of the essence of the data when it's all said and done. And some of our early results from this first year were pretty neat, really. Just to generalize, of course, Goldeye were a new species. We knew that they probably had the potential to move long distances, but we hadn't really documented that. And we really weren't sure what we'd find when it came to Goldeye. And it seemed like they had some very varied movement patterns. They moved upstream, they moved downstream. We did observe 4 of them having used the bypass on Clear Creek, which was really cool. We knew that they had done that because they were one of the first species to colonize upstream, but we did have 10 Goldeye that just jetted down into Montana, and a couple of them were detected in the Yellowstone River. So that's quite a feat. The contrast with that, Sauger really seemed to stay pretty close to their tagging locations. We did have 1 or 2 that moved some great distances. One moved about 47 river miles straight upstream past in the Powder River, past Arvada, upstream of our station near Crazy Woman Creek, and then we never saw it again. But most of them seemed to stay pretty close to where they originally tagged. And none of those Sauger were detected moving downstream into Montana, which was kind of interesting to us. A Shovelnose Sturgeon, we didn't get very many of them tagged. We only caught 5 fish. They were difficult to get our hands on. It was a low water year. But 1 fish that we tagged did travel all the way to the Yellowstone River. And one of the fish that we put a radio tag in the upper Powder near Crazy Woman Creek upstream of Arvada already had a Floy tag, or a plastic tag, very similar to what department stores use to put price tags in things. It had a Floy tag from the previous year that the Montana Fish Wildlife Parks folks put in it in the Yellowstone River. So that was pretty cool to see. So we saw Sauger use the bypass channel, which we really weren't completely sure. We hadn't documented very many of those fish, but a couple of ours did use it. So that was really cool to see too. So what makes fish move in a system? And it's really stream flow. So when the flows change, the prairie fish move. And the stream flow in the Powder River is what you're looking at on the screen right now. On the bottom of the graph, you can see we're looking at May through November. And then on the y-axis on the left is the discharge, or the amount of water, the cubic feet per second at the Moorhead gauge right near the Montana border on the Powder River. The gray dotted line is the 30-year median, or essentially the average, or what you would expect to see at a given time of year. And overall, flows, the dark blue line, were underneath that. It was a low water year. But nonetheless, when the flows came up, the fish moved. And later in the summer, it was a very hot, dry year. This La Nina pattern of weather we're having throughout the whole continent basically gave us not such a great snowpack and a pretty warm, dry summer. So that really did influence the timing, the distances, and the ability of fish to move upstream, but they still did, and they moved around quite a bit. So to put this in a larger context, kind of how we might fit into the larger picture of things in the Powder River and the Yellowstone River Basin, what you're looking at here is a map of the lower Powder River and Yellowstone drainages and the Missouri River drainage. And this is in relation, or comes from kind of the pallid sturgeon recovery program in Montana and the Dakotas. But this intake diversion dam that's circled in yellow, this is the Yellowstone River. This is a major kind of push-up type structure in the Yellowstone River that diverts water for agricultural purposes up there, that in about the same time frame as the Kendrick diversion dam was built, about 100 years ago. It's a nearly complete, or almost complete, barrier to fish migration. And there's a bypass channel that is almost nearly completed and ready for operation on that large river that's going to be operational potentially in the next 6 or 8 weeks. And to give you an idea, this is the Yellowstone River in the upper left, and that is the intake diversion structure. These blue lines represent where the bypass channel has been constructed. So it's basically cutting across this inner side of this bend of the Yellowstone River. And it's a very big channel. It's built for big river fish, and it's a major product of that pallid sturgeon recovery program. That's where most of the funding has come from. But it's going to benefit a lot of other species as well that need better access to upstream habitats. So here's a view of it from the air from a couple years ago when it was being built. It's really big. There were some other pictures that we saw of some construction equipment in it, and they really kind of look like Tonka toys down in there. And I'd say it's probably similar in size to the North Platte or the Bighorn Rivers. And again, it'll be open for business here in another 6 or 8 weeks. This map shows you again that lower Powder River, Yellowstone River drainage, primarily just in Montana. And the dots represent the telemetry stations that the Montana Fish, Wildlife, and Parks and the USGS, U.S. Geological Survey, operate, U.S. Fish and Wildlife Service rather, operate in Montana. And so this isn't something new that we're doing in the whole drainage. It's something that we're starting to do in Wyoming. The bottom of the screen, you can see these yellow dots. Those represent where our stations kind of fit into the bigger picture here. Montana's been doing this for a long time, and it's been a major focus for them has been this pallid sturgeon recovery program up there. They also track other species including Shovelnose Sturgeon, Sauger, and others. And they share a lot of their major interest in these big river fish that are kind of special conservation concern that we have too. This is an example of one of their sites that we visited. This is on the Yellowstone River, right across from the mouth of the Powder River. The Powder River is flowing in right across the Yellowstone right there. And it looks really familiar because we visited it to see how it operated. It's actually a double station. The Fish and Wildlife Service operates this gray box of electronics, and Fish, Wildlife, and Parks operates this orange box of electronics. And so they have both of their stations in the same location. But so, we're working very closely with the Miles City and Glendive personnel with Montana Fish, Wildlife, and Parks. They've been really helpful in this project, and they're really excited because, as if the fish have better access moving upstream, they want to know, how far up they go, and the information that we collect helps put their work in context too. And again, the major purpose of the telemetry work in Montana is to study big river fish. So most of what they're interested in are things like this fish, which is a pallid sturgeon. They've been on the ESA for probably since the 90s or so. They're a really big, obviously they can grow to large sizes, infrequent spawning, long-lived fish. The females mature at about 15 years and spawn about every 3 to 10 years. They can live to be 100 years old, but they need a lot of distance to complete their life cycle after they spawn, and their eggs hatch and drift downstream. There are a few pallid sturgeon that are present or have gone up the Powder River that the Fish and Wildlife Service moved above the intake dam into the Montana portion of the Powder anyway. But they haven't entered Wyoming. And like I say, they're really a large river fish. So to move as far upstream as Wyoming goes, it's possible that as these have more access, they can end up coming into Wyoming up to Powder River, but it's really unlikely. It'll be very rare, at least we expect it to be, because it would only happen under the highest of water years, and it would just be on a seasonal basis. But nonetheless, the lower Powder River in Montana could become important to those fish. Another fish species that, we might see, and that we have probably a much better chance of seeing in Wyoming, could be paddlefish in the Powder River. They're also a big, long-lived species that spawns infrequently. The females mature at 7 to 10 years and spawn every 2 to 3 years. They can live as long as 30 years or more. And there are historical observations of paddlefish that are reliable in the lower Powder River near the Montana border. And, it would be very rare as well to see these in Wyoming, but it's much more likely after that intake diversion bypass starts functioning. The fish that we're seeing here, maybe it was 30 years ago, 40 years ago, they may have used a side channel that occasionally had water in it during the highest of water years that allowed them to get around that intake diversion on the Yellowstone. But there's a fish that we might see. Another fish that's expected to expand upstream is the blue sucker. They're really just a large river fish that it sounds like they really have no interest in tributary habitats, but they kind of stick to big, deep main stem habitats of the Yellowstone River, and we're not really expected to see them migrate up to Powder very far, let alone into Wyoming. But Montana is expecting to see them move up the Yellowstone. So what do we expect to see in Wyoming after that intake diversion starts to function? More shovelnose sturgeon, probably more sauger, and some other species. As far as the others go, they may enter Wyoming during the highest of water years, probably just on a seasonal basis, very rarely. Some paddlefish and pallid sturgeon might move upstream of the intake dam and take interest in the Powder because of its turbidity. But how far upstream they go is really anybody's guess, but it's unlikely that they'll come up this high that frequently. So our plans from this point forward, 2022, this year is the second year of our really intensive study, and it's the final year of our state wildlife grant funding. So we do have a technician who's hired on, dedicated to the project this year. He'll be starting in April. And then, of course, a significant amount of department time dedicated by the Sheridan fish management crew, mostly myself, and also our statewide research crew again, mostly Stephen Siddons out of Laramie to work on the project. And we're planning to do some additional tagging. We shifted some of our money around so that we could probably make the best use of our time by getting some more fish tagged this year with radio tags. And, you know, we're hoping to do more frequent flights this year, particularly around a time when runoff occurs, so that we can try to capture when fish are moving the most and figure out, you know, that gap in knowledge that we have. And beyond that, we think it's worthwhile to continue running these telemetry stations for a few years, potentially at least until we observe fish movements over a high water year. And beyond that, I think as long as we're getting new and valuable data and sharing that with our partners in Montana and them sharing information with us, I think it's worthwhile as well. We have support for that. So some components of the project will likely live on. Probably, I would expect to at least run these receiver stations on the Powder River and potentially Clear Creek for a few more years, you know, and maybe we'll end up asking more questions than we answer. And it's possible that could lead to some graduate research projects, and hopefully, you know, if it's supportive of it, maybe we'll have some opportunities for further fish passage projects to let these populations of fish, you know, repatriate places where they used to be, which will make them more robust and more likely to persist into the future. So that's kind of where this is all heading at this time. I guess that's all I've got. You know, if anybody has some questions, I'd love to take a few minutes and try to answer those. I can stop sharing my screen and I'll hand it back over to Scott.
All right, thank you, Gordon. Neat to hear the updates from that project. I've heard pieces over the years, a little from Travis and then from Paul Mavrakis. So cool to see how it's progressing. All right, so if anybody has questions, feel free to submit those in the Q&A box at the bottom. We can see those and pass them along to Gordon. Gordon, what's the likelihood that there might, or are there other stream diversions or dams as you go further, I guess it's south on the Powder towards Crazy Woman Creek? Are there other potential places where a fish bypass channel in Wyoming would be a potential project?
Yeah, well, there's really no need on the Powder River itself, but on Clear Creek, that's one of the major things we're curious about is, you know, how fish have colonized the stream above the Kendrick Dam and how far upstream they've gone. And if they seem to be their migration sort of truncated or stopping at the upstream end of what they're currently able to go. And that's, I think, at about river mile 43 from the Powder River on Clear Creek, there's another diversion dam that's a complete barrier. And, you know, we don't have an opportunity right now to make a fish passage structure there, but we might down the road. So that is on our of interest to us. That, you know, I can't remember the exact distance from there to the next one upstream, but I think it's somewhat substantial. You know, the Kendrick bypass opened up 36 miles of habitat. So, you know, we could, I don't off the top of my head remember how far it is from that next one up to if we went around it as well.
Got it. All right. Looks like there's a question here. What radio frequencies are used? At what range do the bankside stations detect? And do you identify individual fish?
Yeah, that's a good question. We do identify individual fish. They're ID tags. So they have a specific number, and we have to coordinate the numbers that we use with Montana so that we don't overlap, so that we don't share numbers, so that they're all unique. And the radio frequencies that we use, off the top of my head, they're, oh gosh, it's like 143.3 something. And then there's one main frequency, but then there are some older tags out there that Montana's using. And two of our receivers are the kind of newest and fanciest, and they'll scan more than one frequency. The other two receivers don't. They only do one at a time. But there's a limited number of radio frequencies that we can use. And then the broadcast is kind of at a burst. So like every 5 or 6 seconds, it broadcasts a signal. So these receivers have to listen for a certain period of time on each one to figure that out. And the bankside stations are capable of detecting, I would accurately, probably, boy, it depends. But I want to say it depends on vegetation and things like that, which is more of an issue on Clear Creek, particularly at the upper station than it is anywhere else. Upwards of close to a quarter mile, but probably the best detection occurs within probably, 500 feet or so, something like that. And it's really subject to a lot of interference from power lines, pump jacks, any kind of motors or engines, and just we get weird stuff that pops up in there sometimes that it thinks is a fish or is just random too.
Gordon, I've got another question. Are you using the pit tag still? Is that still part of the process or no?
No, we're not. Bill and Paul and Andrew tried that before I was up here, and I heard the laments of trying to keep the antenna in the stream or in the channel, and then getting really odd data that they're pretty sure a fish passed the antenna, but then they don't see it recorded. The technology, I understand, is a lot better now than it was 10 years ago. But we aren't doing any pit tag work here at this time.
Yeah, I think I remember Bill showing some of that, so that maybe they had a hoop in that Clear Creek bypass channel, and so like you say, fish went through and maybe they saw one that was tagged, but it wasn't recorded. And so they had a mix of data.
There's a certain distance that a fish has to be within that antenna loop that's in the stream. And then it can get interfered with by something that bumps into it, like a log or a stick, or there's just all kinds of stuff. It depends on the angle of the fish sometimes, and if it happens to swim sideways versus straight, and it can be pretty finicky. It can work really well, and then when it doesn't work, it's very frustrating.
One more technology question. So at this point, are there GPS tags for fish of that size?
Well, the interesting thing is that when we're mobile tracking, the receiver itself, if you're close enough to a fish, it is recording a GPS location. But as far as those, I don't know how small. They do make GPS tags but I don't know how small they get, and I don't know if they're used in fresh water. I'm not sure. I know in marine systems they have those. But when we're mobile tracking, like in the airplane, whenever we have a tag detection, it'll record the GPS location of the receiver, which, for us, if we know it's within 1/10 of a mile in the stream, that's pretty close. So that works pretty good.
Yeah. Any other questions for Gordon? All right. Well, good luck this next season. Exciting to see what actually happens out there. And thanks so much for the update on this. Cool to see what's going on and be fun to follow.
Yeah, absolutely. I appreciate people taking an interest in it, and I'm really, just tickled to be able to do it. It's really, really cool.
It is neat project. Yeah, if other questions come in, you can funnel them our way, and we can send them on to Gordon. Thanks everybody for attending, and we'll be in touch. Thanks again, Gordon. We'll see you soon.
Yep, thank you. Have a good evening.
Okay.